treat, guys. We are going to have a live coding session with Thomas Sundberg. Thomas came from Sweden, from Stockholm. And he's going to put all the code in GitHub for you to play with it and use it tomorrow in your work. So will take 1 hour, so you are in for a treat.
30 years now, and they'd never.
Please say welcome with a round of applause for Thomas.
I'm glad too.
Thomas, are you ready?
Yes, I'm ready. Am I?
Okay.
Am I on? Yeah, move it where it should be.
Like this?
In the back, the sound is good?
I don't know. Oh, yeah.
Do you hear us? Yeah, cool.
Okay.
The stage is yours, Thomas.
The stage is mine. Amazing. Thank you. Let's see now. Let me just check. Yep. It seems to work. And this one seems to work. All right. So, welcome everyone. I'm Thomas, and today I'm here to talk about test-driven development, which is something that is very dear to my heart, and therefore I want you to understand that this is something you can do and use at your day job. I use it at my day job, which is as a consultant. But before I dive into that, let me just share with you who I am. And I do these things, which is what you need if you're writing software and develop software. And in my case, also happen to be these. Then we are 2 developers at my client site, so we have to do everything there. We're a couple of developers in a startup, or it's not a startup anymore, a company that I'm running. So you have to do everything, including DevOps. And I don't even know what that means, except that it's complicated. But test-driven development, that's something I really like and use a lot, because it makes my life easier. I can also try to talk about, naming and shaming and stuff, but let's not do that. Let's just notice that this is a way of making my life easier, and that's why I want to share it with you today. I said I'm also running a company, except my own consultancy. It's called Logis, and it's a software as a service thing where you can report or log what you have done as a doctor, for example. So we know too much about what the ambulance helicopters are doing in Sweden at the moment. We also know way too much about what the emergency response cars are doing. Someone is pointing at me. Should I do something? Mike, what is it? I have no idea what you're trying to say. Sorry. Okay, is it different? Oh, so you didn't even hear what I said a second ago. Then I'm going to start over. So I'm going to talk about test-driven development today. And there's many reasons why you want to do this. But the best reason for me is that it makes my life simpler. I'm lazy. I don't want to do things twice. So therefore I write a test and I make sure that it never fails. Or if it fails, I know what to fix. And yes, I'm also running a company called Logis. And one of the things I want to mention is that we are looking for a remote developer. We have a couple of remote developers. Actually 5 of us, because we are distributed. One of them is local here from Cluj, and she's actually sitting there. But she needs a colleague. So if you are interested in a remote gig where we will do Java development and also JavaScript, React stuff in the front end, then this might be something for you. So please talk to me afterwards if you're interested. Definition of done. One needs a definition of done, don't you? And to me, it's working software in production. And it should be used. Otherwise, it's not done, and it's not very interesting. So that's important to me, and that's why my t-shirt says that as well. And yeah, to quote my dear old father, it will always annoy someone, and that's fun. I also happen to own a couple of trombones, and occasionally I play on them. So this is me in the middle of a big band a couple of years ago, playing a solo, which is very uncommon. I don't play a solo in this setting. I do it in some other settings, but not this one. So jazz music is important in my book. Never mind. The anatomy of a test. What is that? 3 things. You have to arrange things. You have to prepare. Then you have to do something. And finally, you have to check something. A test is not harder than this. I promise you. Then there's a lot of details, of course. Details such as you have to set up things. The system under test has to be testable, otherwise it's a pain. And yeah, so there's a lot of things here that is important to think about. But at the end of the day, you have to prepare stuff, you use it, you check. Easy? No. Simple, but not easy. This can be very, very hard, and it can be very complicated. But if you think about it and work on it, it's something you can learn. But to make something testable, you need an architecture that actually supports it. So therefore, I'm going to use today something called ports and adapters, something that a guy called Alistair Coburn came up with 2005, or he wrote this 2005 at least. I guess he came up with it earlier than that. So that's 18 years ago. How many of you were developers 18 years ago? Oh, sorry, am I the only one? Okay, so I'm the only one who was a developer 18 years ago. How many of you have heard about ports and adapters, or for that matter, hexagonal architecture? A couple of you, but not too many, okay? Interesting. It is a way of sharing things. Oh, that was very loud. Okay, I don't know. Well, let's see. If we can lower the volume a little bit, if you still can hear me, that would be nice, because it's very loud for me. I hope it is, if you in the back can hear me. So I should, of course, ask you, can you hear me? And if you can hear me, raise your hand. Who can hear me? Some of you can hear me. Some of you can't. Okay. Some of you in the back could hear me. Good. So the intent of this architecture is to make sure that an application can equally be driven by users, programs, automated tests, or batch scripts, and developed and tested in isolation of its eventual runtime devices and databases. So what we want to do here is separate things. We want to make sure that we don't know about the technology for the database in the model of our application, for example. We don't want the model to know how it was called, if it is a web service, if it is something else. We don't want things to know about each other. Separation. And then it continues to write a lot of stuff, a wall of text here. But basically you connect to something through something, an application port he calls it here. It sends something to the next layer, which will do some magic, probably do some more magic, say store something in database, that is, send stuff to next layer, and then transform it so it actually works in a database, for example. So he has this quote, which I love: "The application is blissfully ignorant of the driver's technology," as in, the model or the core of your application doesn't know where it lives. It doesn't know if it's a part of a microservice with the REST API, for example, and it doesn't care. And we can interact with stuff around it without actually knowing the nature of the things on the other side. As in, a model doesn't have to know that there is a relational database backing it, because that's not important for the model. And one can draw it like this, and this is where the name hexagonal comes from. According to Alistair, all other images were already used, so we had to use a new thing, an hexagon. That's why it's hexagonal architecture. So we have something in the middle, a beautiful domain. In the example we're going to look at today, it's just a simple service. It's actually probably not more than 10 lines of code. but it's very beautiful, at least in my opinion, and I decide today. We have a port to the ugly outside, so we will use a port to talk to a database, or for that matter we will use a port to talk to the domain, or an adapter adapting things that comes from a REST API and adapting it to a port going into the domain. And then we have an adapter to talk to the outside world, and in this particular case, a database, which doesn't know anything about our domain, but knows all about tables and varchars and what have you, boring stuff. So let's implement a to-do list, because that's what you do. That to-do list is the perfect example, because everyone understands how they work, and it's not very hard to do. And things to think about is that we want fast feedback, because otherwise I, as a developer, I will be bored and unhappy. And it's really, really important that I am happy, or a developer is happy, because otherwise the work is boring and we'll probably find something else to do. And we can't afford losing more developers. We want more developers. And we're going to use ports and adapters to ensure that we can test stuff, and therefore make sure that it is maintainable. So this is what we're going to do. I'm going to implement an endpoint using hopefully familiar tooling, Spring Boot. And then we're going to talk to a core application, that is a service inside of this thing. And it's going to talk or store stuff in a database, which I'm going to call a repository. And it's going to be a Postgres repository today. So the first thing we will do is fire a tracer bullet through the entire system where everything needed is hooked up. But I don't want to mess with the SQL database, because they are boring to deal with and it takes forever to work with them. And if I change my mind, as in I don't really know what to store yet, it's a pain to update them. So I don't want that. So I will use an in-memory database, because that's way faster, and I can change things as needed. And then I can keep them in-memory database for quick tests for the application only, which is very beneficial. I said Spring Boot. And Spring Boot has a lot of properties, and there are some of them that I sincerely dislike. All the annotations, for example, are magic, and I just dislike them. There is a blog post by a guy from Warsaw, The Case Against Annotations. Google it, read it. It's written 6 years ago now, I think, it's 2017. It still applies. I'm not as angry as he is, but it still applies. Adam Barsky is the name of the author. And then I'm going to write a test where we verify that the database behaves in a certain way, and then use that test to drive the implementation of a SQL database. So there will be 3 tests today. 2 of them will be integration tests, and 1 will be a unit test. And I will separate them by the name and using Maven for running them at different points in time. You need stakeholders. These are the stakeholders today. The bigger one, that is the one in the background, she's very food motivated, and she doesn't even care if someone wants to take a picture of her, and she's called Gretchen, and the other one is My. And you don't know that, but I know, then I can tell the difference. And these are our stakeholders today, and I have to remember to buy cat food, otherwise they will be angry. And I don't want that, because they will probably tear the sofa if I forget it. They will do that anyway. But talk is cheap. So let's take a look at the code instead, because that's way more interesting. And what do I have here? Well, I have an empty editor, boring. But what I really have is a Spring Boot application that I prepared by creating one online. It has a more or less empty test. It has an application properties that is empty, and it has a main function that is empty. So we don't have anything. I also have a cheat sheet, because I wouldn't remember this by heart. So there's a cheat sheet. Sorry, let's start out with this project is available on GitHub. You can clone it whenever you need. And I propose that you do that. And all you need is here. And if I do this, then that will be easier for me to read. So what we're going to do is implement this endpoint, and then make sure that actually is an endpoint, and then we're going to implement something to store stuff. All right. So the first thing I want to do is sheet, because I have to add a lot of stuff. So the first thing I'm going to do is add a lot of empty stubs, which I just did. So now I have a lot of empty classes that I can use. Some of them are records. We have a controller that will do stuff. It takes a service. The service as such takes a repository, and the repository is just an interface. This is pretty much what we're going to start out with. So the first thing I'm going to do is to create a to-do controller test. And I'm going to add it here. There we go. The looks of this guy going to be this. And if you're wondering, can I do this at home? Yes, you can. Everything is available. So feel free to do it. So what do we have here? Well, we have a test. We have 3 distinct parts. Arrange, act, assert. This doesn't work because it doesn't compile. So there's no point in me even trying to run it. I'm going to create this method. And this method as well. And this should of course not be my name, but let's call it user, like that. Okay, now this guy compiles, so let's run it and see what we end up with. And I hope that you notice that we're going to get a not implemented exception, the first thing that happens, because that's what happens when I created this method. So what's happening here is that we get a request from the outside. All right. We want to convert it into something, and we want to send it to the service for further processing. So the first thing I'm going to do is take the service, and I'm going to create a method on the service that is called create new task, like this. But this guy is a record that holds a lot of strings, because they're good when you try to send stuff on a wire. They are rubbish in our domain though, because our domain, or actually no domain in the world, deals with strings. String is not part of your domain. So if there's anything you could remember from this talk, is that strings are not part of your domain. Understood? Good. So what I want to do here is get a model object that I can use. So I'm going to implement this fly here to model, like that. And it's going to return something that I call a task, of the type task. And that's just a wrapper around a string, but all of a sudden, actually it's not a wrapper around a string, it's a wrapper around 2 domain objects that are wrappers around strings. But I can toss them around, and I will not make a mistake, perhaps withdrawing my phone number from a bank account, because that could happen if I'm just sending around strings. All right. This one is already prepared, so I'm going to just use this guy. There we are. So I take this guy and I turn it into my domain object task. Perfect. This one doesn't exist yet, and it also needs an argument, task. There we go. All right, this is what I want here. And of course it breaks in the service. So I'm going to have to do something here. So here I'm going to just send the domain object to the repository, because that's the only thing this service needs to do at the moment. One day we'll probably have to do more things, but not yet. So this is what it... no, I can't. So if that is the case, please raise the volume a little bit. Okay. I can try, but... okay. So the repository should just send this further and be done with it. Now it should be stored somewhere, and that's all we need here. So let's run it and see that it doesn't even compile, because this guy implements it. So we need to do this. And now let's run it. And now we break in the repository. And this is an in-memory repository. So what I'm going to do now is make sure that I have a database, because I need a database. And my database is going to be a private final map with a user as key and the list of tasks as data. And this is my database. I'm going to implement it as a hash map, because that's fast and that's good enough. One could do a concurrent hash map or something, but we don't need that. Okay, so I'm going to store this. And the way to store it is to do database.get, using a user as a key, and task has a user. So this is all I need. But it's actually so, I don't want to do that one, because it could return null, and I'm not interested. I'm interested in an empty list or the actual value. So therefore I'm going to do this. And now we have a list of tasks. Okay. And the tasks should contain the new task. So let's add that guy. And now we need to put it back into the database. Or actually, yes, we do, if the list were empty. So let's do database.put with the key and the tasks. That's it. I'm going to refactor this guy a little bit, because I know that it's nicer if I have it like that. Let's run this and see where we end up now. Bummer. Not implemented. But let's look at where we ended. So this step is actually working now. We are going all the way down to database. Unfortunately, we can't get back yet. So we need to get back as well. Meaning that this guy, get tasks, has to be implemented. And it isn't. But we're going to ask the service for help, because the service probably know how to get tasks. And if it doesn't, we'll teach it. And we're going to have to send this guy a domain object, because the service doesn't deal with strings. Strings is, again, not part of your domain. So we're going to create a new user and use the string I had there as result. And I want this guy to return a list of domain objects, task, that I call tasks. No, there's a typo here. There, tasks. Okay. And this guy I want to convert into something we can return. So I'm going to implement from model on this guy that will take a list of tasks and return a list of task response. The response is just a wrapper around strings, because strings are easy to send around as JSON. Right, so let's implement this. Okay, And let's implement the other one so it compiles. And as you already saw, I have prepared this. So I can get rid of this guy. And I can get enable that one. So what I have here is a list of tasks. And they will be transformed into something we can send over wire as JSON. We can probably send this one as well, the list of tasks, but I don't want that, because then I'm not hiding my private secrets. And this application has some private secrets. We want to tell the world how it deals with the tasks, because the world doesn't have any reason to know that. So therefore I'm wrapping it again. So let's run this and see where we end up this time. It's not implemented in the service properly. No, it's not. Because we haven't asked the repository for return. That's correct. And then we want to do repository and we want to do get tasks from the repository. And it takes a domain object user as an argument. And I'm driving all of this with a test. I just unplug this guy and I will plug it. And let's do it again. Something is not really working as it should here. We are terribly sorry for that. Or I am very sorry for that. Oh, success. And while you were waiting, I was actually working. So I just implemented this method that the interface requires. And we're going to see that we stop at it. That's great. So last step, I hope, is to ask the repository, the database, to actually give us these things. No, I'm going to use this guy. Get to default, because if we don't have a task, I don't want to return null, I want to return an empty list, because they are not dangerous. So let's run this and see. Again, bummer. But why? Oh, look at this. This is a proper error, not just a compile error or implementation error. So this guy fails because I'm sending this and I'm expecting this. And there's a dash here. Bummer. And this is one way of using test-driven development. This is the first step today. And let's hope I have time to do the rest of them. Maybe. So I just created an in-memory solution, and the idea has a little bit of opinions. I don't care. That's good. But this one is, so this was the first step, the tracer bullet. We went all the way through all the layers we want. Next step is to make sure that this is actually an endpoint. And one could say that, oh, but that's easy. Yes, it is, if you know. And it's easy to screw up, because if we're talking Spring Boot here, we're talking about annotations, and lots of them. So we need to verify this. And the first thing I'm going to do is to create an integrated test that actually does this. And the internals of this guy is these things. That's a long one, 70 lines. What do we do? Well, the test is only these 5 lines. And what I have here is arrange, act, assert. Maybe the request should be in front of the response. So in this particular case, I want my partner Malin to buy some Mintu. Not to forget to buy Mintu. And if you don't know what it is, it's a very minty Finnish specialty. It contains alcohol. If you like it, you like it. But the first thing we want to do is add the task, then get it, and then verify stuff. So let's look at the add task, which is this one. So what I have done is I created helper methods for the complicated and uninteresting stuff. How you talk to a database, in this point, how do you talk to an endpoint is actually not very interesting. It is necessary, but not interesting for the business. So what I do here is I use a web test client, I create some stuff, connect to it, I actually call it and I verify that we got is created back. That's it. Then I'm interested in getting things. Now it's a little bit more complicated. So in this particular case, I have a web test client. We do a get with a path where the username is a path variable. We get the response here, and then we verify the response. It should be okay. And then I do some digging. And at the end of the day, I'm able to get the response body as a list of task responses, which means that I can assert it here. So the test here is not very complicated. The details, how to talk to the endpoint is. But if we run this, what will happen? It won't work, I can tell you that. But what did happen is, I don't know if you saw it, but I saw it. There's a 404 here, not found. And the reason for this is, of course, that there are some annotations missing. Annotations that can only be checked runtime, which is one of the critiques I have against annotations. If I could fix things compile time, it would save me a lot of time. But I can't, because that's how it is. So let's go to the controller, and let's look at the cheat sheet and notice that we need to add some annotations here, namely these annotations. So now I need to do this. Yes, and yes. Let's run it again. And this time it won't work, because now we are entered spring land, and that includes a lot of magic. So this one failed to start, and the reason being that this guy, service here, which one can see is red, it has to be bean, or you can annotate it with component if you want. And it turns out that this guy also have to be that. So I'm going to go to the in-memory thingy, annotate it again. And these are not checked compile time, so that's a problem for me. There we go. No, this is still red, but I am pretty sure it's going to work. And there's a 404 here, and the reason being that there is no annotation for the post. So we have to fix that. There we go. And we want to do that here. And we want to import everything. And this guy as well. There we go. Let's see now if it works this time. No, there's a not found again, which I saw. I don't know if you saw it or not. Now I lost my cursor. There it is. This time we got a 404, but it's a get task that doesn't work. This is boring. Okay, so we need to add the notation for the get method as well. That's this one. Okay, let's do that. And let's run it again. Okay, so now we got something that is actually a little bit harder to see. We are getting something that is null, but we expected something else. And the reason being the fact that we don't deal with the request body, which is yet another annotation. So this guy is a request body, which we need to annotate. And then we got something empty back. Okay, that's pretty good, because we are returning an empty array when we don't find the user. And why don't we find the user? I mean, we have it here on line 24. But there's another annotation missing. And it is the path variable that should be here. Now, people might think that this is boring. Why do I have to do all of this? But I couldn't test it, or I couldn't verify it without my integration test. So that's why I'm using it to drive this implementation. And finally, we got a proper error, not just tooling errors. Where is my cursor? Can't find it, sorry. It says that we're trying to get something here, and there's a difference there. So the solution here is, of course, to go to the test, to do controller integration test, and notice that we are sending in this task, and we're expecting this task. So if I get rid of this dash, it will probably work. And it did. So I was able to write an integration test, and I was able to use it to add and find all annotations needed, which is really important, because otherwise this application won't work. But we can't find it unless we have something that actually checks this, or actually we have added the annotations. And how would you know which you need, which annotations you really need? Well, you run it manually, and 2 hours later you probably realize that, oh, I forgot this path variable. Or you don't run it manually. All right, so that was the step where we added something for a proper endpoint. Which I'm going to commit now. There we go. And we are now in the position where we want to make sure that the database actually works. So we have been able to fire traceables through the system, verify that the endpoint actually going to work, and now we want to check that the database actually going to work as well. I have 19 minutes left. Let's see if I can make this, maybe. The first thing I'm going to do is to cheat, because that's what you do when you run out of time, or actually when you know that it's going to take a long time to build this. There we go. So what did just happen? Well, I added stuff into the application properties, so I will be able to run Flyway. Flyway is a way of migrating or maintaining schemas in a database. There's something called liquid base that people tend to use as well. I disliked liquid base because it tried to solve the problem in a complicated way. So I use Flyway instead, and it works very well. I need a data source configuration. I need an interface to keep SQL, because I'm going to use JDBI, which is an alternative to more magic, as in hibernate magic, which is also complicated. And is there any more? Yes, there's one more thing here that is actually really important. This guy. So this data source will fire up Postgres, and this little magic thing will ensure that we fire up test containers. So all of a sudden we will have a Postgres database running in Docker at a well-known port, or some port this guy will know, and we will be able to use the real thing. I've used H2 a lot, and it works very well. But in this case, I want to play around with Postgres, which works reasonably well as well, except that it takes a long time to start things. Okay, so that's what I prepared. So let's start out with a test that will make sure that I actually implement this properly. There we go. And the content of this guy gonna be this. So let's look at what I have here. This is a little bit magic or strange perhaps. This is an abstract test class. And why is it abstract? It is abstract because I want to be able to recycle it or reuse it. So I want to be able to run this against the in-memory database, and I want to be able to run it against the proper SQL database. And I want to run the same tests. And when this test passed in both environments, I know that the in-memory database is functionally equivalent with the real thing, which means I can use it for testing in the rest of the system all over the place. And that's going to be fast compared to fire up Postgres, a Docker in a Postgres, Postgres in a Docker, and then do stuff and do stuff. That's slow. I can use the in-memory database all the time, almost. But let's make sure that this one runs, and it doesn't because this one is abstract. So I need to do a little trick here. And the trick is that I will extend this guy somewhere and run it from there. So this is the trick I'm going to use. So I have an in-memory to do repository test. And I'm going to implement it like this. So this one inherits the to-do repository test. One of the few examples where inheritance actually is a good idea. We tend to prefer composition over inheritance because we learned that inheriting stuff is complicated. And what I do here is I'm going to set this package private variable repository to an instance of the in-memory. And if I run this, it should work, I hope. No, it doesn't, because I need more stuff here, because the database configuration is added. So I need to add a dependency, bummer. This dependency, so I can get the data source to actually work. Let's see if it works this time. No, because I have to press this key. And now? It doesn't work. And the reason being that there's a compression failing here. So the test here is about Emil. Emil is about this high, maybe that high by now. He's 3.5 years old. He lives with his mother, and he knows that in order to be able to cook, you need to chop wood, because they live in a small cottage and they use a wooden stove. They do have electricity, but his mother likes it that way, so they do it like that. Let's run this again and see if it works this time. Yes, it did. Now we can use this test to drive out the implementation of the SQL database, which is very good. Right, so I did that. And I did that. I need to add this active profile on some places on the integration tests, because the data source need to be found. And one way of doing this is to set the active profile in Spring Boot to dev. Now we're going to read the properties in the application-dev file. And we're going to have to do it here as well. There we go. And then I want to create a SQL to-do repository IT, because I want an integration test to do this. There we go. And it can be implemented like this. So I have a Spring Boot test, I have an active profile, I'm extending this guy, so it should work. I don't seem to have something called SQL repository yet, so I've got to fix that. Then I'm outer-wiring things, and finally I set it to the package private variable repository. So the first thing I'm going to do is actually just to copy the in-memory repository, paste it here, and call it SQL repository. That's cheating, but fake it till you make it. And if you're wondering, is there a company in Sweden called Fake It Till You Make It? Yes, it is. I'm the CEO there. We fake everything. Right, is there anything else I need to do? Don't think so. Let's see. Well, if I run the same test, of course, everything will work. So I need to run the SQL repository test. And it works. Perfect. And of course, the reason it works is because I'm using the in-memory thing. But I did annotate with components, so it was outer-wired, and some stuff is actually working. But we're not talking to the proper database yet. So, what I need to do now is make sure that the SQL repository is implemented properly. And I will do that. And I can do that by going here and replacing all of this with this. So I'm implementing the to-do repository. I have a magic thing called to-do DAO here, which is going to be the home for the SQL. Then I need to create a key here, because the idea is that you should be able to have more than one task. So I'm going to do that, use a UID for it. The to-do DAO needs a couple of methods, so let's implement them. Like that. And it also has to fetch stuff. Like that. And it has to be a bean. This one is angry because it's not a bean. Whatever bean happens to be. But it's Spring Magic, and we just have to conform with that. So I've created a bean here for the to-do DAO. Okay, does it compile? It seems to compile. I didn't get an error. Does it work? And the answer is, of course, no, it won't. And the reason it doesn't work is a little bit hard to understand here. But the gist of all this mess is the fact that we don't have SQL implemented or needed. So we need to add these things. And now it's a point in time when those people who like Hibernate will start sighing and think that this is very complicated. And one could argue that, yes, this is very complicated, but I'm in control, which I like. So in this particular case, the tool JDBI will help me out to run this particular query in this particular situation. That's good. It still doesn't work. I know that, because we want Flyway to actually implement the table. But I have prepared some stuff here, so maybe we would work. Oh yeah, look at this. The thing here is that when we fire up this application, Flyway will pick up this setting and it will try to create this table, and Flyway will contain, or it will keep a table of its own in the database, so it knows which version of the schema it is. So it doesn't apply them more than once. But this is great when you develop stuff, because now you can change your mind if you're not working on a shared database, for example. But if I run this, I'm afraid it won't work, because there is another annotation missing. Again, and the annotation missing is the get thingy. So let me steal this guy and add it to the DAO there. There we go. So now I have some stuff here that will search in the table after some stuff and return a domain object. So the only thing I need to do now is to make sure that we have an adapter that can transform it from the format the database will give me, strings, into something that we can actually use. So this is the price I have to pay for not using Hibernate. And it's a price I really love to pay, because it's worth every, whatever the currency has to be, is. This one will convert whatever it needs to do into this one. So what we will do here is we'll take a result set and we will transform it into a task. Okay, let's run this and see where we end up. You already saw that I'm going to throw an exception if it doesn't work. And let's see where we end up here. And I wish I knew where my cursor was. There. Not yet implemented. Perfect. And the task mapper. Could you go there? No, you don't want to go there. So this guy has to be implemented. And luckily, there is an implementation available here. So if I do this, I take my result set and I map it, create a domain object, take another column, create a domain object, and finally I create a domain object that we actually are using. Should be done. Wow. It worked. Let's run these tests in Maven and let's see if it works here. Oh, it did. It took 1.8 seconds. So if I have good unit tests, I can get really fast feedback. If I need confidence, I can run all of the integration tests as well, like this. But it's going to be way slower. 9.4 seconds, so 5 times slower. But it works. So we have confidence that it works, and we have fast feedback if we want to. And let's commit this. There we go. So we ran the tracer bullet through the application, we verified the endpoint, and we verified the database. So the conclusion today is that I used some tooling that I hope you're familiar with. JUnit, AssertJ, and I didn't mention AssertJ, but yes I did. Spring Boot, because it's very popular. I don't really understand why sometimes, but it's popular and people like it, so let's use it. JDBI, because I don't want to be angry, and I get angry when I have to work with Hibernate. And then Flyway, because I can maintain my schema in an easy way. test containers because now I can run Postgres as needed. And Postgres, well, it's worth it, the money I pay for it. I don't pay anything for Postgres since it's open source, so it's a very affordable thing. I used ports and adapters, so I could separate things and make each part easier to test. And these guys, they get something to eat. And therefore they don't attack the sofa. They will anyway. So, this was me talking about test-driven development. I think we might have 1 or 2 minutes for questions.
Yes,
and if that is the case, no questions.
There?
Yes, first of all, thanks for the presentation. It was really nice. I see you express a great hatred towards annotations, and I wonder if you have any alternatives to that.
Oh yeah. I would love to use Drop Wizard, for example, in this case, but they lost the war about making small applications. But Drop Wizard, they use annotations as well, but they do more of a compile time configuration and therefore checking compile time. So the problem here is, I guess, that there isn't any really good alternatives often. I also use Spark Java a lot. Spark Java is a really small framework or library for writing REST endpoints. There's no annotations at all there, and it works pretty well. And now you get feedback compile time, which is really good. So there are alternatives. They're not very popular or common, I'm afraid.
Okay, thank you.
Okay, then I guess it's time for lunch. Thank you very much for listening.
Thank you so much. Now you are invited for the lunch break, 1 hour. And in this room, the presentation will start again at 3 o'clock. Enjoy your meal.